Hey everyone, and welcome to The Explainer. Now, if you've ever traveled to Rome or, even just scrolled through pictures of it online, you absolutely know the Trevi Fountain. It's a total masterpiece. Millions of people flock there every single year, right? They toss their coins over their shoulders, snap a quick selfie, and just marvel at those incredible marble statues. But here's the thing. Almost every single person standing in that square is completely missing the actual marvel. Today we're going to look past all that beautiful Baroque marble and pull back the curtain on a staggering feat of ancient technology.
So I really want you to think about this for a second. When we look at massive, roaring water features in our modern cities today, what exactly powers them? What keeps all that water flowing so relentlessly? Obviously, we immediately think of heavy industrial pumps, huge electrical grids, maybe subterranean engine rooms just humming with modern tech. So, what exactly is running the Trevi Fountain?
Okay, let's dive into this because the answer is honestly kind of mind-blowing. It's not electricity, and there is absolutely zero modern machinery involved. It is a 2,000-year-old invisible engine. We're going to reverse engineer this incredible monument right now and see exactly how a continuous flow of water has been arriving at this very specific spot in Rome for over 2 millennia, completely uninterrupted by power outages or blown fuses.
All right, moving into Section 1, the fountain's secret, a hidden masterpiece.
So when you look at the Trevi Fountain, you're looking at a grand 18th century facade designed by the architect Nicola Salvi. And it's super dramatic, right? You've got these giant figures of Oceanus and those rearing seahorses, but Salvi didn't just pick a random pretty spot in Rome to build a sculpture. He selected this precise site for a very specific reason. He built this massive piece of art as the monumental endpoint, the termination of a working ancient hydraulic system. The water you see rushing out from beneath those statues today, it's coming from the exact same springs that Roman engineers tapped into over 2,000 years ago.
Let's step back in time. Section 2, designing the Aqua Virgo back to 19 BC.
Picture this, it's 19 BC. Rome is going through a massive population boom. The city is just exploding, and with all that rapid growth comes a desperate need for resources. Enter a guy named Marcus Vipsanius Agrippa. He was a general, a statesman, and Emperor Augustus's right-hand man. Agrippa looks at the Campus Martius area of the city, which was filling up with new public baths, gardens, fountains, and realizes they have a huge crisis on their hands. They desperately needed clean, fresh water. So he greenlights the construction of a brand new aqueduct.
They called this massive project the Aqua Virgo. Now, the basic idea sounds simple enough. Just channel fresh spring water from the countryside right into the heart of the city. But the execution? That's where it gets conceptually brilliant. Roman engineers designed a channel stretching over 20 kilometers. That's more than 12 miles, starting from springs east of the city. And here's the kicker. Almost that entire 20-kilometer route was designed to run completely underground. Digging and plotting a subterranean tunnel of that length, back in 19 BC, it's just staggering.
Section 3, the genius of gravity, zero mechanical aids. Now, what's really interesting here is the stark contrast between how we solve problems today versus how the Romans did it. Think about our modern water grids. They're loud. They're incredibly energy intensive. We rely heavily on mechanical pumps, motorized engines, and a constant, unwavering supply of electricity to move water. But the Aqua Virgo? Zero mechanical aids. No pumps, no water wheels, literally no power grid. Its success rested entirely on gravity, geometry, and unbelievably careful planning. They let natural forces do all the heavy lifting.
The entire secret was the slope. The only reason the water traveled those 20 kilometers from the springs to the middle of Rome was because the channel followed a precise, uninterrupted downward angle. But it was a seriously precarious balance. If the engineers made the slope too steep, the water would rush way too fast, scour the stone, and eventually destroy the channel. But if they made the slope too shallow, the water loses its momentum, pulls up, stagnates, and becomes totally useless.
So how precise did this slope actually need to be? Roman surveyors calculated a drop of just 3 centimeters per 100 meters. Think about that for a second. 3 centimeters is barely more than an inch, and 100 meters is basically the length of a football field. So they had to drop the floor by an inch every football field. And they did this without lasers, without computers, and without GPS. Using only basic sighting instruments and their own practical experience, they coaxed the water forward deep underground, centimeter by centimeter.
Which brings us to Section 4, surviving centuries, built to last. And this brilliantly illustrates why putting the Aqua Virgo underground wasn't just about saving space. It was a strategic masterpiece. Think about it. An underground channel protects the drinking water from contamination. It shields the delicate stone structure from freezing temperatures and severe weather. But absolutely most importantly, It hid the city's water supply from enemy attacks. During a siege, those towering, beautiful stone aqueducts above ground were massive targets. But the Aqua Virgo was practically invisible. Plus, it was way easier to maintain over the centuries.
Let's walk through this timeline, because the legacy here is unmatched. They finished construction in 19 BC. Fast forward to 410 AD, the infamous sack of Rome. The city is literally falling. Invaders are pouring in, and many of those great elevated aqueducts are deliberately smashed to cut off the city's lifelines. But the Aqua Virgo? It basically went unnoticed. Through the collapse of empires, barbarian invasions, and all the dark instability of the Middle Ages, the water just kept quietly flowing beneath the streets. Centuries later, the Trevi Fountain gets built right at the end of it, and it's still operating today.
Finally, Section 5. Engineering Eternity, an unbroken streak.
Out of all the magnificent, legendary aqueducts the ancient Romans built, the Aqua Virgo stands completely alone. It is the only Roman aqueduct that has operated continuously from antiquity to the present day. I really want that fact to sink in. Over 2,000 years. There are no moving parts to break down. There's no engine to refuel, no circuit boards to fry. It's just an unbroken, 2-millennia-long streak of fresh water answering the simple call of gravity. As our source material beautifully puts it, this system is a quiet but powerful example of how Roman engineering prioritized longevity, function, and harmony with natural forces. They didn't try to bully nature with heavy machinery, right? They understood the local terrain and the physics of water so intimately that they were able to work in total harmony with it. It's a standard of permanence that our modern hyper-complex infrastructure still profoundly struggles to match. So, as we wrap up this explainer, I want to leave you with a bit of a provocative question. When you look at the roads, the massive power grids, and the high-tech water systems running our world today, systems that completely fall apart without constant maintenance and continuous electrical power, ask yourself, could any of our modern infrastructure survive the next 2,000 years? Honestly, probably not. So the next time you see a picture of the Trevi Fountain, don't just look at the marble statues. Think about the invisible 20-kilometer engine right beneath the surface, quietly proving that sometimes the absolute greatest technology is the kind that works seamlessly with nature. Thanks so much for joining me today, and keep asking those big questions.